Hello, Mr. White, right?
Maybe I am. Maybe I'm not.
Okay, so last lesson we talk about the longest substring, and a given string is lowercase only. And we want to find out the length of the longest substring between two equal characters. For example, BAAB, the longest substring between two equal characters is AA, which is size of 2. And for this AA, it's 0, right? And if AB, if there's no equal characters, we return -1. And the last lesson we talked about using the hash table actually. Hash table, the keys value. The keys is the characters. The value is the first time this character appears, the index. And then we iterate over the string. And for each character, we check if it first time appears in the hash table. If it's the first time, then we simply remember the first. So basically, this index is the leftmost index, which we can find. Yeah, we can use the find or index if it's the first time, and we remember it in the hash table. Otherwise, we can compute the length between current index and the leftmost index. Subtract 1 because we only want the length of the substring between the two equal characters. On, because we are iterating the characters from left to the right once. This is on time, and on space because we're using the same table. Okay. One straightforward idea is that the brute force. We haven't talked about brute force, yes?
Brute force is boring.
It's boring and slow. So brute force, we can just brute force the pairs, and then we check if it's equal, and we calculate the length. So it's very simple, right? For I in range n, for j in range I, if the string I equal string j, if it's an equal character, then we can calculate the answer. Count the character, maximum answer at the beginning is -1, and then the j is the left index, I is the right index, so I minus j -1, right? And then return answer. The time complexity for this one, you see these two nested loop, so it's O(n) squared. So this is brute force, very slow, right? But the good thing about this brute force is the space complexity is O(1) constant. Right? We don't need a hash table. Okay. So since we are given this string with all lowercase, so we can just iterate, right? Iterate over each character. There are only 26 characters in the alphabet from A to Z. And for each character, we find the rightmost index and the leftmost index, if it has any, right? Sometimes it doesn't appear in the string, then we just skip. And now with this right and left, we can calculate it. Okay. So answer. The same answer equals -1, right? Because if it doesn't have these two equal characters, we return -1. For the character, right? The character in A to Z, right? You want to iterate over A to Z. There's a few ways to iterate from A to Z, and there's a better way, which is string. We use the string.ASCII. Do you still remember what's ASCII? Underscore lowercase. ASCII, American Standard Exchange Information,
Isn't it also ASCII art?
ASCII, remember this?
Art as well.
Yeah. Ooh, you did some research, yeah? Using the ASCII, the character, basically the characters on the keyboard to draw the art, okay? ASCII for A, this is 65. ASCII for lowercase a, this is 97. ASCII for number 0, which is 48, yeah? The space is 32. Okay, and the return key, yeah, return key. This is 13.
So you could basically generate a code just using numbers.
Yeah, this is kind of mapping. Okay, so you can map the character with the numbers with a byte. This is from 0 to 255. This is a single byte, right? Remember, single byte. Okay, 8-bit single byte, right? 0001111. Okay, this is 15. Okay, so from ASCII, this is basically saying that C, let's iterate from A to Z. Okay. Another way is that for C in range 97 to 97 plus 26. Odd A returns 65. CHR 65 returns A. These two functions are the reverse. Can you come up with two functions which are reverse of each other? I think you know it. Reverse of each
Join
other.
and string.
Join
And
and what's that? Join and
split.
yes. These two are reverse. So odd A gives 65. CHR 65 gives A. Let's find the rightmost, which is I equals S dot R find C. Okay. So we talk about the find the index. When we want to find the character in a string, if the character we are looking for is not in the string, then the find returns -1. The index returns an exception, throws the exception, okay? Exception is just like the error. It's a more aggressive way of reporting the error. Does it make sense? So if you're asking the computer to do something which it doesn't know how to do, then you will scream. That's kind of the exception. And find is more gentle way of saying, okay, returns -1. Asking for the index, okay, I return -1, and then you need to interpret -1 is not found. If it's exception, okay, then it means that the computer scream. I can't find it, okay? We use rfind, so then we have to check if I not equals -1. If not equals -1, it means that we have seen this character appear in a string, right? Then we have to find the left index, right? The left index is s dot find C, right? Then we have the right index, we have the left index, then we can compute, we can count, am I right? So answer equals the maximum answer. Okay, so the right index and the left index. The right index is I minus j minus 1, right? And return answer. Okay, one question. Can we replace find with index here? Remember, index, when the C is not in the string, when the C is not in the string, then you will throw the exception. Can we replace the find with the index here? Here we are saying that we want to find the rightmost index, and if we find it, then we want to find the leftmost index. We find the rightmost index of C in a string. Okay, so that's why we have a check if it's not equal to -1. So now we want to find the leftmost index. So can we make sure, can we guarantee we can always find the leftmost index of the character C?
Yeah.
Yes. A, B, B, C, D. Okay, what's the rightmost index of C? We find it, right? Can we find the leftmost index?
Yeah.
Yeah, of course, yes. It's already in the string. We can find it anyway, right? We use this rfind to find it here, this way, from right to the left. Once we make sure it's not equal -1, it means that the string is, the character C is in there. And then we can always find it from left to right, right? Since it's there, I can find it from left to the
But
right.
what if it's A, C, B, C, D?
Yeah,
It won't be the same way.
it won't be the same, but at least I can find it. I can replace this find with index. Remember the difference between find and index.
But
Index
what if it's
is
slower?
no, it's not slower. Okay, so we can replace this find with index. It doesn't matter because we can find it. We can count the characters between, which is I minus j minus 1. This is the rightmost index. This is the leftmost index, and -1. The time complexity for this one is O(n). The space complexity for this one is O1. Okay, why is it O(n)? Look, this one is 26 iteration. This is basically O1 constant. Okay, and then for this find and rfind, this is O(n) because we need to go through the string from left to the right or from right to the left to find the characters in a string. Okay, I think that's it for today. Bye bye.
Bye.
Bye bye.
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 Bye.